So my name is Nagin Cox, and I'm a space systems engineer, and I've been lucky enough to work in both civilian, commercial, and military space operations. So I started out as part of the United States Air Force, working as a space operations analyst at Cheyenne Mountain NORAD, and that was part of my background in how the military is getting more engaged in space, and especially how the focus there is on the Earth while using assets to make sure that we protect our planet. So that's my background on the military side and commercial. I've also worked in some commercial companies, which now is becoming a huge part of space, is space that isn't run by space agencies. But a lot of my experience is at NASA's Jet Propulsion Laboratory, where I currently work as a space systems engineer on deep space robotic missions, and specifically Mars is my area of focus. So we have been working towards answering some important scientific questions for literally decades. And our first rover on Mars, the Mars Pathfinder Sojourner rover, was the beginning of that process. And Spirit, Opportunity, Curiosity, and Perseverance have all made additional steps in finding out what Mars was like in the past. And it turns out that Mars once had oceans and rivers. It was much more like the Earth, but that was about 3.5 billion years ago. So what we're trying to find out is, was there ever microbial life on Mars in the past? So the Perseverance rover, one of the rovers that I'm currently working on, is primarily gathering samples. So we are looking for rocks and samples of those rocks that will tell us if there was life on Mars in the past. Again, microbial life. And those samples are going to be brought back to the Earth by the next robotic mission called Mars Sample Return. So we actually expect to have samples back on the Earth in about 2031 that will help us answer this great question of what was Mars like in the past? And then hopefully we can understand, why did it change? Why was it once more like the Earth, and why is it not now? Well, so let's see. It has certainly been interesting to note that the more we learn how to look for signatures of life, the more we find. The first questions when I started in deep space robotic missions was, is there even water elsewhere in the solar system? And the answer to that was yes. And then, did Mars once have water in the past? And the answer to that was yes. And was Mars once habitable? That was the Curiosity rover's mission. And the answer to that was yes. So as we look, we find evidence that a lot of the building blocks of life might be much more common than we thought. So is it possible that we will find evidence that Mars once had microbial life? It is definitely possible, because now we know there were water, the building blocks of life, but as Carl Sagan said, extraordinary claims require extraordinary evidence. So before we say something as life-changing as there was once life on Mars, we have to be sure. And that's why we're bringing the samples back, because there is a limit to what robots can do, to what robots can figure out for us, these robotic missions. And so we're going to bring back the samples, so like the moon rocks, they can be distributed to universities and institutions around the world, and we can collectively figure out if we thought there was once microbial life on Mars. First of all, it's a blast to be part of the first generation Martians, is what we've come to be known. So those of us who live on the Earth but work remotely on Mars. When we first land a rover on Mars, we do work on Mars time. And that is, in fact, a Martian day is 40 minutes longer than an Earth day. So for the first 3 months, we are rotating through. Our work days start maybe at 8 in the morning, then 8:40, then 9:20, then 10, and eventually we are coming to work in the middle of the night. It is grand fun because you're working together with a group of people to explore a new part of Mars, but it's also very hard on your body to be basically moving a time zone every day. So we do that for about the first 3 months while the vehicle is new and while we're all together and learning how to operate this rover on Mars. But then eventually we move into a more of a modified Mars schedule because that is more sustainable and that's better for us as humans long term as opposed to trying to stay in sync. And so of course when we're on Mars, we won't have this same issue of trying to stay in sync with Mars time. So, you know, we all know about working remotely, and so we work remotely, right? Far away on Mars. And just as we know, if you're working here in Europe with somebody in the United States, you might have your telecon with them at a very different time than if you're working with people in Europe. So it's the same, it's just an even farther time difference. We hope to send people to Mars in about the next 20 years. And that actually looks promising that that date will hold because kind of the whole time I've been in the space business, it's always been, we're gonna send humans to Mars in 20 years. But this time it feels more real. And I think that's because we've made advances robotically and also because there are more players. There's competition, there are different space agencies involved and different commercial companies. And that's the kind of intellectual curiosity and intellectual drive that actually moves us ahead. So 10 years ago, I might have said, oh yeah, we're probably gonna send people to Mars in 20 years. But now it feels like that's actually going to happen. And we're looking at an international crew, probably 2 to 8 people. And so we hope that there will be humans following after our robotic missions on Mars very soon. So it is part of our nature to expand our horizons. Living on Mars is not the same as living in Antarctica. We have a parallel for this in that Antarctica is a very inhospitable place, but we've had humans living there for over 100 years. It's still very small groups of research scientists and the engineers and infrastructure needed to support them. But even in Antarctica, we have breathable air. Mars is not a place that humans can naturally live at the moment. And I think like any other place, we'll be interested to explore it from a research and science perspective. Colonies are likely to be a little further away. And we're still not talking about, you know, giant colonies where a good percentage of the Earth goes to live on Mars. It's more of a frontier where there will be groups of people that are exploring this new world, but not large-scale colonies anytime soon. We shouldn't think of it as, oh, we are finding these other worlds, let's go there and mess up ours. Earth is still our home, and we need to take care of it. And the more we learn about other planets, the more we really learn about our own and how important it is to care for our beautiful blue marble. So this is my first TNW, and it has been wonderful. I'm so glad that I was able to be here yesterday and really get a feel for the environment. And it seems like it's, you know, many conferences are kind of very buttoned up and, you know, very specific agendas and tracks. And it seems like this leaves room for more conversation, more creativity. It's probably not clear whether more connections are made in some of the informal events versus the formal. So I think it's a very interesting mix of people, I think 97 countries or some amazing number like this. It seems like a wonderful place for people to gather professionally, but also to make the connections that last beyond the 2 days.